G'day chemists. So I hope your prep is going well. We're going to look at some questions today and from module 5. Just two. These were, help you out. Just some things to go over. So here we have a nice little multiple choice question. I quite like this question. It's got a bit going on for it. It is a band 5 or 6 question. That's who it's aimed at. So let's have a quick read of the question first. We've got 3 gases, X, Y, Z, and they're mixed in a closed container and allowed to reach equilibrium. Okay, so we've got a closed system. A change was imposed at time t, that's labeled on the graph down here, and equilibrium was re-established. The concentration of each gas, that's what's on the y-axis, is plotted against time. So let's have a look at what's actually happening here. First thing, there's a volume increase. And that's why we know that, because the concentration of each gas decreases instantly. It's a boom, all at once, and they all decrease at the same time, because as the volume increases, therefore the concentration of these reactants and products is going to decrease. Another interesting thing there to note is if this had a solid in it, its concentration would stay the same, because solids don't change in concentration like that. Another thing to note is that the concentrations all change in proportion to their original concentration. So for example, X, which is up here on 0.1 concentration, goes down by 0.3, whereas 0.6 goes down to 0.1.5, and 0.4, which is 1.5 of, 0.6 is 0.6 is 1.5 of 0.04, and it goes down by 0.1. So all those changes are equivalent to their initial concentration. Now, according to Le Chatelier's, as the volume has increased, concentration and pressure decrease. So as the pressure has decreased, we now favor the side with most gases, the most gas moles, which is why we have this increase in Y and Z. So let's have a look at what we've got, right? What we need to know is that Y and Z, for starters, are going to be on the same side of the equation, because they both increase to re-establish equilibrium. So that takes A out straight away. Then we know that we have more moles of gas on the right-hand side. Okay, more moles of gas on the right-hand side, because that's what it's trying to achieve. So that takes out B, because B is 2x, that's equal, so that's the same, so it wouldn't have that sort of a change on it. However, with C, we have 2 over here and 4 moles of gas. With D, we have 1 mole and 2 moles. Now, the next clue is how Y and Z have changed in relation to each other. What we see with Y and Z is that Y and Z have both increased by the same amount. This means they're in the same molar ratios. And as they're in the same stoichiometric molar ratios, that means the answer has to be D. So D is our answer with this one. So let's have a look at this Ksp question. A 100 ml saturated solution of calcium hydroxide at 25 degrees Celsius contains 0.173 grams of calcium hydroxide. We want you to calculate the solubility product, the Ksp, at 25 degrees Celsius, and then we want to explain why the undissolved solid is not included in the expression for the solubility product constant. There's actually a clue there into how to do the next part. So let's go to our answer page. Okay, so we've just given ourselves a bit more room here to write. First things first, we notice that they've given us a number. It happens at 25 degrees Celsius. Now, because we're doing a calculation off the numbers given to us, it's actually a bit irrelevant, but we do need to know that it is temperature dependent. So it's irrelevant, but Ksp is temperature dependent. We need to be able to write the formula for calcium hydroxide, which is Ca brackets OH brackets 2, and that's a solid, obviously. It's a saturated solution, and that means it's going to be in dynamic equilibrium. And we have the mass, which we have to turn into moles, because that's how we run concentration. So, as with all chemistry, probably the first thing we'll do with most questions is we'll write down our equation. Dynamic equilibrium, which means it has that as a symbol, and it goes from calcium hydroxide to 1 calcium ion in aqueous solution plus 2 hydroxide ions, and that balances it all out for us. A Ksp equation, remember the clue it gives us in part B, is Ca in square brackets, concentration. So the concentration of calcium ions multiplied by the concentration of hydroxide ions squared, because it's got that 2 coefficient at the front. The coefficient becomes an indice, and that's just how Ksp works. And this is from the concentration of calcium hydroxide, which we'll get to that in a second. So the first thing we need to do is we need to work out how many moles of calcium hydroxide there are. And this becomes 0.73 grams, our grams, over the molar mass of calcium hydroxide, which is 74.093 grams per mole. Our next step, so we just divide that, and that gives us 2.33 times 10 to the negative 3 moles. So we can then put that into our concentration. Concentration of calcium hydroxide, remember that's the one we've got to start with, is moles over volume, which is 2.33 times 10 to the negative 2 divided by 0.1, which gets us to 2.33 times 10 to the negative 2. So, for reasons like stoichiometric relationships, we can work out then what our concentrations of our calcium and our hydroxides are. So, the relationship for calcium is 1 and calcium hydroxide is 1 to 1. So, nice, 2.33 times 10 to the negative 2. Whereas our relationship for hydroxide is 2 to 1, so it's a double. So, it becomes 4.66 times 10 to the negative 2. And that's because of this little 2 up here. So our Ksp, we come back to where we were before. We multiply those together, remembering to square the value for hydroxide. And that gives us 5.06 times 10 to the negative 5. Almost finished. Don't forget your answer statement. So therefore, Ksp of calcium hydroxide at 25 degrees Celsius, because it is temperature dependent, is 5.06 times 10 to the negative 5. Now, part B, explain why undissolved solid is not included in the expression for the solubility product constant. This is just a simple marker. The first question was aimed at, said, band 4.5. This is aimed at band 3.5, and that's because solids are constant in their concentration, which is a non-thing, so they don't have a variation in concentration. So we just give them a value of 1. And because it's product over reactants, that would make it a, this value here, over 1, so we can ignore it. All right, cool. And we'll see you next time with more prep questions. Bye.